As for fieldwork exercise number 3, we will determine the area of polygonal field using tape. For introduction, a common problem for a surveyor is the calculation of the surface area of a specific field. The fields are often regular, which makes direct calculation of their areas difficult. In such case, fields are divided into a number of regular areas, of which the surfaces can be calculated with simple formulas. All areas are calculated separately, and the sum of these areas gives the total area of the field. The only objective in doing this fieldwork exercise is to develop and acquire skills of determining the area of a polygon in the field using tape by dividing the area into triangles. And for the instruments and accessories to use are range poles, measuring tape, markers, either chalk or marking pins, and plumb bobs. And in order to determine the area of the polygonal field, we will use the method of area determination by base and altitude, the area determination by two sides and an included angle, and area determination by Heron's formula. So first, we will use the area determination by base and altitude. The instructor assigns the location of 5 points in the field, and the students will mark these points with marking pins or chalk. Name these points, which will serve as the corners of the polygon, and we will name it as A, B, C, D, and E. The chief of party divides the polygon into 3 triangles by taking into consideration that the division should be easily measured. Name the triangles as A1, A2, and A3. Measure the base of the first triangle that you chose in the polygon using tape. Then measure the length of the altitude of the first triangle. The determination of the altitude is part of taping operation. To know the altitude is perpendicular to the base, we will use of 3, 4, 5 method, and then record the length of the base and altitude. To get the area of the triangle, divide the product of the base and altitude to 2. To determine the total area, the second and the third triangle will repeat the method that made in the first triangle, and then add all the area. In second method, we will use the area determination by two sides and an included angle. In the same field described in the first method, we also be use the method by changing the designation on the corners, and we will use the F, G, H, I, and J instead of A, B, C, D, and E. Also, divide a polygon into 3 triangles. Measure any 2 sides of the triangle chosen and record these measurements as sides A and B, and then record. To get the area of each triangle, area is equals to 1/2 times side A times side B times sin theta. To solve for theta, theta is equals to arc cosine times side C squared minus side A squared minus side B squared all over 2 times side A times side B. While the total area, take the summation of areas of A1, A2, and A3. As for the last method, it is the area determination by Heron's formula. We also be use the same field as the first method, but change the designation on the corners, and we will use it as K, L, M, N, and O. And so, divide the polygon into 3 triangles. Measure all the sides of the first triangle that you chose, and record these measurements as side A, side B, and side C, and you can choose any triangle to start with. To get the semi-perimeter of each triangle, the first triangle must multiply its perimeter to 1/2. To solve for area using Heron's formula, Substitute the values of the semi-perimeter, side A, side B, and side C to the equation. To determine the whole area of the polygon, take the summation of areas of triangle 1, triangle 2, and triangle 3, where triangle 2 and triangle 3 must repeat the steps of what the triangle 1 does.